Let me introduce first of all, Mr. Marshall, Peter Marshall, the Apache Druid database. Oh, sorry, that's the title of your speech. You already know about that. Peter Marshall led the technical evangelism team at Imply, a company founded by the original developers of Apache Druid. He has 20 years of architecture experience in CRM, EDRM, ERP, EIP, digital services, security, business intelligence, analytics, and MDM. He is TOGIF certified. Oh my goodness, what a guy. And has a BA degree in theology and computer studies. So serves as a technology evangelist. Breach.
Thank you, everybody. Thanks very much for inviting me to speak. This is my escalator slide, I think they're called technically. Yes, I am. I do have a BA in theology. And to quote someone from a meetup in Milan a couple of weeks ago, I'm probably the only evangelist that you've met who actually is qualified in theology. But we're not here to talk about God today. No questions about God, please. I'm a technology evangelist. I work with the open source community, the open source Apache Druid community, out of the community team at Imply. And in this talk today, I'm going to talk a little bit enough about what Druid is, who Imply are, cover a little bit about what Clickstream Analytics is to me, and then kind of relate what I've understood about Clickstream pipelines and what they are and how they've been built in the open source community, and then highlight some critical techniques for people who are using, have adopted or are thinking about adopting Apache Druid. And just to thank Gian Molino, who's actually going to be speaking as well at this conference, for his input, and one of my colleagues called Helmar Becker, who's based in Munich, and lots of other people who've helped me build this slide deck today and to do this research. So let's get going. What is Apache Druid? Who are Imply? If you look at the Druid project website, Druid is defined as a high-performance real-time analytics database, and it's used where anybody needs fast ad hoc analytics, where they need instant data visibility, when they're supporting use cases that are put in front of lots and lots of different users, so high concurrency, and where that user interface needs to be highly interactive. Imply was founded in about 2015. Fanjin Yang, who is the CEO of Imply, at that time kind of set our mission. And he said that we're going to devote our energy to making it as easy as possible for people to use Druid and to build awesome data applications on top of it. If you want to hear a bit more about the story of where Druid came from, nearly 10 years ago now, Eric Cheddar, we affectionately call him Cheddar, is our field CTO at Imply. He was recently interviewed about the whole story behind Druid, and I really do recommend taking a listen to his interview with Software Engineering Daily. You can also read the Druid paper. It tells you in detail, excruciating detail, some might say, about the review that they did of different technologies that were available at the time and why they decided to do the crazy thing of writing a new database. One of the first adopters of Druid was Netflix in 2013, just a few months after it was open sourced. In 2015, after the first project committee met, the adopters included eBay, PayPal, Cisco, and Yahoo. By 2016, well, lots of people who are using it for video streaming analytics, for infrastructure monitoring, Clickstream analytics, API health monitoring and reporting, all sorts of stuff. And to kind of echo what Robert was saying a minute ago, this is all being backed by, and they are supporting a community. People are all being brought together by the principles of the Apache way. It's a community I'm very happy, very proud to be part of. I know lots of people are too. And of course, it's a community you can be part of as well. So they created this database. They wanted it to be fully scalable. They wanted it to be able to scale in and out, up and down for storage, query, and ingest independently, to enable people to bring data in real time and in batches. The kind of database you can use for all sorts of statistical queries, really to free people from needing to pre-compute statistics further upstream, to deliver a real ad hoc experience, and to let engineers remove anything that gets in the way of delivering data to end users in a low latency fashion. And underneath the hood, Druid is a blending of different database technologies that have served us and those Silicon Valley giants we know very well. Eric says that this is the true innovation of Druid. He says it's taking what we know and what we've learned and applying it to create a new type of database that's focused on end user experiences. Druid brings together the ingestion and flexible schema and text search capabilities you'd find in traditional search platforms, optimizations for time series data. That's critical for all sorts of business-based decision-making, like comparisons over time periods and so on, and the efficient storage and super fast statistical computations you find when you use really awesome columnarized databases. And it's applying that learning that's the magic to Druid. It really does work. Ingestion can scale to many millions of events per second if you need it to. The query engine can support lots and lots of different users with lots of statistical questions they might ask. Again, not fixed by pre-computation. And that columnarization, that optimization, that compression enables you to store data really cost effectively and to bring that unified view of real-time and historical data together. So what do I define as Clickstream analytics? I'm not going to bother defining it myself. Lots of people who define it themselves. I like this quote from an Clickstream analytics project owner. They said, it puts you closer to your end users. And if you know what your end users want, you're better able to serve them. So take this example from a news publisher. The front page remains the prime real estate on channels like this. Using the new field of Clickstream analytics, publishers are able to find out whether a campaign they're running relating to maybe a new news headline is bringing the right kind of visitor into the site, whether it's getting them to have a long and fruitful journey with us that achieves our goals that we have for them. And Clickstream data tells the story of what visitors we've had, of what they're like, what they did while they were with us, and whether a goal that we have for them was actually achieved. So a visitor starts their journey, that's technically a session. It might give us some hints about where they were before they got here and why they came. And inside that session, while it's live, are page views and user actions that tell us what they actually did during the session. Now, hidden inside that haystack of data is the stuff that tells us about the conversion events, about abandonment, about attrition, and so on. Now, of course, they don't just hit one page or do one thing. They do lots of things like designing kitchens. And they do that inside multiple sessions, multiple visits to a site. And that is just for one particular visitor. So the volume of data is massive, but it's important to get at. Because if I get that, I can drive loyalty by promoting my website. I might have different advertising tactics or different promotion strategies. I might try and do something that reduces the churn rate of my site. If I look at the session data, i.e. the journey that someone's having through my site and what they're doing, I might personalize that experience and test one experience against another experience. I might tune my navigation elements. I might try and create a first visit, first buy behavior so that they come to the site, they spend some time and they buy that holiday. Or I might do something even more extreme and give them the page where they buy the thing immediately, do a conversion at the point of entry. And in terms of the site design and the way the pages are laid out, maybe I'll change what products people are seeing by understanding the causation and the correlation between different buying habits. Lots and lots of examples. For me, what matters in all of these and what I see is that reaction time matters. Companies that need to react quickly to compete in the market that they're working in. And reaction time in getting statistics, therefore, is really important in actually getting the data that we need to create those statistics as quickly as possible, in being able to make comparisons between what happened today and what happened a month ago as people change and develop the channel to make visitors ultimately happy visitors. So let's look at some pipelines. Enough pretty slides. The most common producers that I've seen are usually some kind of JavaScript code. It's embedded on a page, on a website, for example. On a mobile device, it might be some kind of component written in whatever language has been used to create the mobile app. Now, I am old, I'm afraid to say. When I started in IT in 1998, all I had was IIS logs, for those of you who still use IIS, and it would just tell me like what page had been requested. That's gone now. Now what we're talking about is components running on the client side. They tell us what the client saw, and it gets rid of any caching that might happen in between, for example, and it can provide a lot more information than just what page was requested. Sometimes the data is emitted when someone does something, like clicking a submit button. That's very common in web and mobile apps. But Clickstream is bigger than that. Sometimes the data is emitted on a timer. That's very common in video streaming, for example. And the data is very likely to change. As the business needs to adapt, so does the data. And that was one of the drivers for schema on read approaches in data ecosystems. Clickstream data very often ends up on some kind of event hub, especially Kafka. I've seen that emerge as a kind of a quasi standard for this kind of data with one really big good reason. If you imagine you have 150,000 servers, if we still call them servers, and they're running all these websites in 12 different companies in different geographies, different markets, with Kafka, people are able to unify all of these assets, put them into one stream of click data, showing all the user actions, and then people can view that through the lenses of sessions, of visitors, to understand the effectiveness and the efficiency of the business entirely. And that's something at this scale, which still blows my mind a little bit that this is possible. But when it's produced, Clickstream data is very often just this stream of actions, right? It's a timestamp with some attributes that we want to filter or sort or group our results by. And we've got some measures, the things we want to create the stats from. Now, the session information that tells us about the person's journey and information about the users themselves that we want to analyze our data by is very often absent from the click data. And without that data, it's very hard to understand the journey through the site or to analyze who took that journey. And I think that that's because there's two key constraints in the HTTP protocol. First of all, it's stateless. It's very easy to know when a session starts by looking at the user actions, but it's not very easy to understand when it ended. And determining the end timestamp of a session is often calculated following business rules, some of which can get really quite complicated. I've seen some great examples in the Kafka community where KSQL is used to work out sessions, for example. Secondly, HTTP, it's a network protocol, right? It's very old. It's not to collect demographic information about visitors. It's there about network communication. So there might be some fingerprints we can use to identify things about people, like a persistent cookie or some credentials or some browser identifiers, or maybe even IP addresses, if we're still allowed to use those. I can never remember. And so once again, we need to do something. We need to use some kind of intelligence to work out visitor information. So somewhere in the pipeline will be data processing. It's very often in batch that abstracts a number of data sets to create session and visitor data, align it with campaigns, etc. And this processing brings these three types of data together in a model that the user can navigate through. Sometimes that model ends up on S3, sometimes it ends up in HDFS before it's picked up by some kind of database tool for end user analytics, whatever that might be. And you can see that the traditional Clickstream pipeline may well be fed by streaming data, but they come to this kind of halt in the middle. They come with, therefore, latency. We get delays, we get pre-processing. Excuse me. What kind of problems do people face if they're just dealing with Clickstream data anyway? Well, first of all, it's very hard to capture Clickstream data. It can come in from multiple sources, multiple servers and services. When it arrives, the database that we're going to use needs to be able to scale it to deal with the large volumes of data, not just the user actions, which there could be millions a second, but of all the data we want to enrich that with, the stuff that decision makers actually need. And that sheer volume of data caught many people unawares, people like me. And one channel might have millions of unique visitors. They create billions of click events. And the business then says, well, do you know what? I think we need to have more people on our website. So then the poor old database administrators, they're having some kind of nervous breakdown about how on earth they're going to scale their database to do that. Both the length and depth of the data mean it's hard to understand as an end user. It's not easy to have a conversation with it. It's hard to decide up front what the filters might be we might need, or what measures we've got to look at, or what the visuals might end up being. Besides the fact that a broad number of stats in Clickstream are about count distinct. Count distinct is horrible. Everyone hates count distinct. It's computationally very expensive. And you think about magnifying this over the size of the data sets in Clickstream, well, it turns into a nightmare. So anyone who was trying to use early generations of the database systems, the things I grew up with, like SQL Server, you know, they're tunable, but they're ultimately not fit for purpose. Sorry, SQL Server. If you use vertical and a tensor, they can be very expensive to scale with a number of concurrent users. Data lakes can be really tricky, etc., etc. So what about those people who've picked Druid? Well, adoptees of Druid can speed up delivery of this data, especially when they're using something like Flink or Spark streaming, to effectively keep the data flowing, to keep it coming from the source to the end user. They might adopt a Lambda architecture. They might combine streaming and batch data. They might use fast and slow lanes, one that helps help people make instinctive decisions about urgent matters, things that are time critical, and then have another lane which has higher accuracy, maybe contains data with higher levels of confidence, data that allows comparisons with data sets that are many years old. They use the data compression that's inherent in Druid, like secondary indexing, type-aware compression, to keep their storage under control, because after all, this does boil down to money. They use columnarization to allow data to be wide, enriching this click data with lots of data from those other data sources, especially visitors. They make use of time-based partitioning in Druid that allows them to compare metrics over time really quickly, with the query engine picks that stuff up and does it in parallel, including making comparisons between live and historical data. And they scale their ingestion and storage capability to stay ahead of the massive amounts of data that pipelines like this generate. If you look at the use cases for Clickstream, I won't go into all of them, you'll be glad to know. Please go and look at the Powered By page instead. Hulu, Twitch, and Netflix are doing it for streaming video analytics. Nielsen for advertising. Game analytics is a great story for mobile app analytics, a wide range globally. Druid has some critical functionality that keeps coming up again and again in use cases. So I just want to highlight some of them very quickly. People are using sub-partitioning very effectively. So within Druid, we can take our main partition, which is always time, and add a secondary partition. That's really important for Druid's ability to prune what data it picks up first. And it's especially important if you're in a multi-tenant environment, if you need to segment your data into different markets, maybe have different end user experiences segmented. Very common if your filters are very common. You might use enrichment at ingestion time in Druid. You might do that upstream, especially important for visitor demographics. You might use roll-up. To quote one of the engineers that I know very well called Will, he said, if you haven't got that many pixels on the screen for your visual, why have you got that many rows? So if we use roll-up in Druid to summarize the data so it fits onto the number of pixels that people have. Approximation is a very important technique in Druid, especially hyperloglog for distinct count and theta sketches for set analysis. Streaming ingestion, definitely very important in Druid. We support Kinesis and Kafka. Hopefully Pulsar will come soon to get that data in and make it available immediately. Compaction is really important when dealing with late arriving data. That's like a defragmentation technique. If we've got out of order data or late arriving data, we need to make sure that's treated well. They use some mechanism to stay ahead of changeable schemas. So Druid does do schema on read on these time-based partitions. You can also adapt your ingestion specification so that you can just let Druid handle the schema. Some people go to the extreme of using Jenkins and GitHub to actually control the ingestion spec. The whole schemas get updated at once. Expression handling. I very often have seen people taking stuff that's always the same at query time, and instead of doing it at query time over and over again, which is really wasteful, they front load that and do that upstream. A very silly but obvious example would be regular expression parsing. And also creating tables that are what I call hyper lean, by which I mean that there may be some filtering or some set of dimensions that people always use, and they'll create a table that's specifically for them that operates extremely quickly. And then they have another table where the query times might be a bit slower. When it comes to funnel analysis, very important in Clickstream, I am not going to talk about it because this guy who's called Itai Yaffe is a fantastic speaker, and I really recommend watching his video on funnel analysis. He used to work at Nielsen. He's just a great speaker anyway, but he talks in detail about funnel analysis. There's 3 techniques that I've seen. People are using theta sketches to build things that look better than this. The idea of this slide is to tell you that you can slice and dice the different membership of different members as they go down the funnel using theta sketch analysis. Importantly, to say when the data is implicitly in time order. Secondly, some people enrich the click data. This is a very common solution that's used in advertising, where upstream what we're doing is we're working out whether a particular user action is indicating that someone is in a particular funnel. This is great for Druid because it's columnarized. Calculating funnel membership is really fast just by using sum. Another solution is that people will talk about enriching the session data. So they will add a column, for example, that indicates whether a session ended at a particular funnel. And again, brilliant for Druid. Druid's great on group by operations. We just do a group by on that column, and we can kind of do some clever maths to work out what the funnel was. It's a great solution because if you've got multiple funnels, you're then able to just add another dimension for each of your funnels and then do group bys on that funnel. Sessions, you cannot get away from. Sessions are very difficult to work with. Sessions are long lasting. Sessions are vague things. There are some things you do not know about the session when someone visits your site. For example, when they left your site. You can only know that when they've actually left. But they are critical. These are the kinds of analytics we can do with what I call X-event data. And I want to give props to the people at the University of Belfast who wrote a paper actually about music that gave me this list. Please go and have a look at that if you're that way inclined. It's really important to understand sessions and to do session analytics. It tells us about how difficult the journey was. It tells about progress, how they got from A to B. It tells us about the goals they achieved, why they took the journey in the first place. Really important list of analytics we might want to do. There are times when it's useful to work out session data at query time. Obviously, maybe the business rules might change a lot, for example, but it's very expensive. So most people, when they're using Druid, are doing some kind of session processing upstream and allowing Druid to do OLAP. Let Druid do OLAP, not be your session worker outer, if that's the right words to use. But the demand for instant visibility, for high flexibility, what Druid promises is quite new, really. And when it's absolutely essential for people to get session data now, there is one design approach that's been emerging. It's called the Delta event pattern. I heard from this from Gian. In some kind of processor upstream, we basically have a state engine, and its job is to look at the incoming data and to emit deltas that enable us to do a good number of statistical calculations to work out what the current value is. So, for example, how many cats do I have in my shopping basket? What we do in this machine is we pump in 5, the state machine or the processor in the middle goes, in order for the sum to give me 5 cats, I need to emit 5. 4 comes in, -1 is emitted, therefore I get 4 cats, etc., etc., etc. It doesn't work for everything. Not all the maths work, but it's a good starting point, I think, in how all of us data engineers are thinking about how to solve the problem of analyzing data that hasn't arrived yet. So, thank you, everyone, again. We've had a lightning visit in this talk to Druid and to Imply. I've talked a little bit about the importance of Clickstream analytics. I've looked at some of the common issues that Clickstream pipelines have when we're dealing with real-time analytics. And I've dashed through some of the critical features in Druid that people use in Clickstream. When I work with anyone wanting to make Clickstream analytics flexible, fast, full of fresh data, I have this checklist in mind. I talk about ingestion scalability. I talk about the need for different aggregates and what they are and how quickly they need them. I look at how fast the filters need to be and what techniques need to be applied. I talk to them about time-based comparisons, things like A/B testing. How are they going to achieve that? What do they look like? And importantly, massively importantly for Clickstream, how are they going to use approximation in order to solve their problem? Why is this important? It's about getting data into the hands of people who need it. Because when we put that data close to our users, if they can work out what their users want, they are better able to serve them. Thank you, everyone. And now I think we have time for questions.
We do. So if anyone has some questions, please feel to drop them in chat. By the way, thank you very much, Mr. Marshall. That was As you said, that was a dash through, but that was some really cool stuff.
It's like the fastest talk ever.
Oh, just about. All right, but this may be pretty short here because I don't see any questions yet. So, but let's just hang out and see.
Cool, no worries.
No, I think actually you did a too good of a job there of laying everything out. Well, we got 2 minutes left. Are there any particular pluggables that you want to mention as far as Imply or Druid or your Twitter or anything?
Well, I've always got to plug my Twitter account. I need those followers, John. That's what I need. There's lots of community activity. I should talk about the community. So I spend a lot of time in the community channels. It's a lovely place to be. We have Druid Forum. Please come and talk to us on there. There's the Apache Druid Slack channel. You can find all that information on the community page. There's also the LinkedIn group. Please join that. Lots of professionals in there. And we have Druid Summit next week, which is really exciting. And I'm going to be doing live training in London. I've actually got to meet people in person, believe it or not. Shock. So we're doing that next week. So yeah, it'd be lovely to meet anybody and say hi in the channels if you see me.
All right. Well, with that, I'm going to say thank you again to Mr. Marshall. Thank you again for attending. I'll probably see you in some other conferences in the attendees list. So, oh, I'm sorry. We did have one quick question. Can you compare the solution between ClickHouse and Druid?
Oh my goodness. Well, that's a difficult one.
You got time. I'm not going to end it yet. So go ahead.
Well, do you know what? I'm not an expert in ClickHouse, I have to say. My expertise is in Druid, but that's why I love this. I have to say, that's why I'm really looking forward to watching some of the other talks in this conference, because I really want to understand it myself as well. So I can't give you an authoritative answer, I'm afraid. That was answered like a politician. I know, I do apologize. Like I should be running for president or something, but yeah, I don't know enough to answer the question, I'm afraid.
No, it's okay. I think you do better than most of the other people running for that office. So I think we're safe. So, all right. Thank you again, Mr. Marshall. I'll go and end it here, and I'll catch you all in some other conferences.
Lovely. Thanks everybody.
Thanks, everyone.
Bye.
Bye now.